All right. Welcome back, everyone, to George James and Associates Research Tools channel. I know it's been a while since I have posted anything, any content. And today what I wanted to do is I want to start a mini series of thinking backwards when it comes to mathematics. And I say this because the way that math was always explained to me, and it was always taught to me growing up, is that it was basically a three-step process. So step number one, let me put it this way. So actually, let me label this. So traditional math pedagogy, and that's the way that things are taught, right? Pedagogy. So it consists of three steps, right? So step number one is introduce the formula, right? Whatever the formula is, this is the formula, and then that's what it is. And then step number two is plug in values into the formula, right? And then step number three is essentially, just calculate the answer or the solution. And so here's the problem with that, though, is that the way it's traditionally taught is, yeah, it's great in class when you see the formula and the values are so neat and tidy, and they're presented to you in almost a very apparent, obvious way as far as plugging in values in the formula. But then when you encounter a word problem or a realistic scenario, it isn't obvious where the values go into the formula. So this kind of leaves you wondering, well, what am I supposed to do? Right. And so I want to move away from this model. I'm going to go ahead and put this up here. But I want to move away from that model because I don't believe, for those of us, myself included, who have a hard time understanding math and learning math, this is not the way to teach somebody. Now, if they're already good at math, then it doesn't matter, right? If someone's already good at math, I'm going to make my X a little bit smaller here. If someone's already good at math, then they're going to learn it regardless. You can just throw them a textbook oftentimes, and they'll self-teach, right? But for the vast majority, at least of Americans, this isn't the case. I don't know about people who live outside the United States, but here in America, this is the way that math is typically taught. It's awful. This is why I got derailed from my math learning progression essentially in third grade. And it wasn't until I started learning statistics that things just naturally clicked, but I realized that it's not true for everybody else. And so that's why I sort of take pride in my ability to boil down statistical and other mathematical concepts, econometric concepts, into easily digestible steps. Okay, so here's the deal, right? So today we're going to talk about tax equivalent yield. And what that is, and this is even when you look at, if you were to look this up on Investopedia, it tells you that tax equivalent yield, so I'll say definition one, right, is that it is the amount that a taxable investment or taxable bond really must yield, right, in order to equal or be as attractive as a tax advantage bond. And here we're talking about a municipal bond. I'm not a fan of that definition because really when you look at the formula or when we derive the formula, it's really more like the amount a tax advantaged asset of inferior rate of return must yield in order to equal the superior non-tax advantaged asset. And I suppose this is just two different ways of saying the same thing. But I am a big fan of this second definition. I didn't realize I just watched the Investopedia video again. And the Investopedia definition is the first one, but I like the second one better, to be honest. And I'm just going to pause this really quickly because I need to do something. I'll be right back. All right, we're back. Okay, so So here's the deal, right? And from this, you can probably sort of understand or start to lean in the direction of what the problem is. So we have a real world problem. And actually, before I say that, in case you don't know what a bond is, so a bond is a security, right? And it represents ownership of the company that is issuing the bond, right? So you become a creditor, right? So you, the bond purchaser, become a creditor. I'm sorry, it's not ownership, it's indebtedness, sorry. Stock is ownership, sorry. It is indebtedness, that is my mistake. I don't want to redo this entire video, sorry. Indebtedness, I would say from the company that is issuing the bonds. My apologies, it's not ownership, that's a stock, sorry. Indebtedness from the company that is issuing the bond. So you, the bond purchaser, become a creditor of the company. The company owes you money, right? So what happens is that, right, this is you. You can tell my fantastic drawing skills, right? So this is you, and this is the company, right? And this is the bond. And so the bond, think of it as a contract. It's not really a contract, or I guess it sort of is. So you basically give the company money, and the company gives you this bond, right? Which is kind of an IOU, and that about every 6 months, the company is going to continue to pay you interest. And then at the end, right, all the terms in the bond, at the end, once the bond is done, the company gives your money back. That's called the principal, right? It returns your principal to you. Now, of course, there's various risks, right? There's interest rate risk, there's liquidity risk, there's all this risk, right? And some bonds are more marketable than others. So there's the default risk of the company. There's all these risks associated with bonds, but bonds provide that stable income, assuming that the company doesn't become insolvent or something like that. So anyway, that's what a bond is. So now quickly, what we're going to do then is let's paint a picture of a hypothetical scenario. So let's say that you only have, it doesn't matter what X is, right? It could be 10,000, 50,000, right? It doesn't matter. It could be 5,000. Say it's a small number, right? Relatively small number. You have only $5,000 to invest, or X dollars to invest, doesn't matter, right? So where should you invest it? And assume you're extremely risk averse, right? So no appetite for risk. So you are only going to consider bonds. Okay, so over here, we have option 1. And let's just say this is a high yield corporate bond, right? That returns, I don't know, let's say 7%. It's pretty good, but it's fully taxable, right? Let's assume you're not doing this inside of a retirement plan or something. It's fully taxable, right? And then over here, option 2 is I'm in California right now, so we're just going to say it's California. It can be any state, right? California municipal bonds that yields, let's do 4.5%. And the yields are per year, right? So yield is per year, even though you're getting paid every 6 months. So then here's the deal. Here's the problem, right? The problem is that this is not an apples to apples, right? It is not apples to apples. Why? Because you have to pay tax on this, but you don't have to pay tax on that, right? You don't have to pay taxes on the municipal bond because it's a tax advantaged asset by itself, regardless of what account it's in. The high yield corporate bond is fully taxable, right? At least that interest is going to be taxed normally at ordinary income rates. So you don't know, then you cannot equate this apple with that apple, right? It's really apples and oranges. So this is an orange and this is an apple, right? That is the problem. So then how do you compare the two? How do you compare them? Well, we have this thing called tax equivalent yield. And instead of just giving you the formula, we're going to build the formula, right? I think that's a much better way of teaching people math, is to build the formula, derive the formula from the problem. You start with a problem, you don't start with the formula, you end with the formula. So tax equivalent yield is what we're going to do. Remember the definition from just a moment ago. So tax equivalent yields. All right, so what do we need to do, right? Well, we need to understand a couple of things, just basic math, right? Like arithmetic. And so if you have a whole number and you divide it, you want to increase this number, right? So if we start with a municipal bond of 4.5%, we want to know once we don't pay taxes, right, on this 4.5%, what is that the equivalent to? Is this better than the 7% that we had to pay taxes on? Well, we don't know. So we need to figure out, okay, so we have this number here. Even though it's in a percentage, we're going to keep it as a whole number. Otherwise, it's going to throw everything off. So 4.5%. How do you make that larger mathematically? Well, you can make it larger by multiplying, right? We can multiply it, but we can't multiply it by a percentage, right? And when we're talking about taxes, ordinary income taxes, we are talking about a percentage, right? Like let's say 25%. Well, if you multiply a percentage times a percentage, then you're going to get, right? It's going to wind up being in decimals, or you're going to wind up dividing by 100 because everything's in percentages. So 25% of 4.5%, that doesn't work, right? So we can't multiply percentages to make this larger. So to make this larger, you've got to divide, right? This is our other option that we have available to us. So if you divide by a percentage, then it will increase this value, which is what we want. And we know we want that because we want to know if after we account for not paying taxes on this yield, is it going to be larger or smaller than this value, right? We want to know where the two stand. We want to create that apples to apples comparison between the high yield corporate bond rate of 7% and the tax equivalent, or I'm sorry, the tax advantage municipal bond of yield of 4.5%. So once we account for taxes, does this 4.5% grow to be beyond the 7%? Well, it depends, right? The next question is how much tax are you paying on, or would you be paying on this income? Depends on your tax bracket. Okay, it depends on the tax bracket. Okay, cool. So here's what we know then, right? So now that we have this out of the way, here's what we know is we know that we want the municipal bond yields, right? The MBY, and that needs to be a whole number, right? That's a whole number. And we're going to divide it. Now, what happens if we divide it by the 25%, right? And we're going to do this in decimal. So what happens if we divide it by 0.25? So 4.5 divided by 0.25. And then let's take another example and say that we can wind up in the 25% tax bracket or the 37% tax bracket. Okay, well, I'm bringing up my calculator right now. So if we do 4.5 divided by 0.25, that's 18. Huge, right? 18%, which is kind of crazy. Now over here, you would expect this to be even larger. You would expect if you're paying more in taxes, you're saving more by purchasing the municipal bond. So that yield is going to be even greater than 18%. That's what should happen, right? So then what we're going to do is we're going to clear our calculator and say 4.5 divided by 0.35. But it's only 13, it's rounded to 12.8857 or 13. We can round to 13. That's 13%. That doesn't make any sense, because what should be happening is as we're paying higher and higher taxes, we're saving more and more money by not having to pay those taxes. Okay, so this isn't going to work. So then how do we figure out a way, right? What are we supposed to do down here to divide by 0.25? And instead of having this be 18%, it should be more realistic, as in we're saving by not paying more in taxes because we're in a higher bracket. This yield should be greater. Because right now, let me reword this a different way. Over here, the 35 or the 37%, I think I did 35%, but sorry about that, but same thing. 25 to 35%. That means that instead of going from 18, it shouldn't go down to 13. It should go even higher. The problem is that basic arithmetic is if you want this number to be even higher, you need to divide by a decimal that is smaller. So for this to be higher, this needs to be smaller. Okay, well, how do we do that? How do we do that? Well, you can take a 1, which is the same thing as 1-0 or 1.00 in decimal form, and you can subtract your tax bracket from it. Why? Because it doesn't make any sense to pay more than 100% in tax. As far as income taxes go, 100% is the max. So let's benchmark this essentially and take that 100%, subtract out the 25%, and then that's going to be 0.75. And we're going to do the same thing over here. We're going to do 1 minus 0.35. And now we're going to see, right, these were the whole percentages here, and these aren't going to work, right, by just dividing by the larger numbers. So instead, we're going to do this now. We're going to take 4.5 divided by 0.75. So now this is 6%. And then over here, we're going to take 4.5 and we're going to divide by 0.35. I'm sorry, 0.65, 1 minus 0.35. Let's try that again, 4.5 divided by 0.65. There we go, 6.9, let's round it to 7%. So this is 4.5 over 0.65, that's smaller than 4.5 divided by 0.75. So 0.65 is smaller, but because it's in the denominator, it's going to push this number up higher than it is over here. So our tax equivalent yield here is 7%, whereas the tax equivalent yield here is 6%. And so we did that just by understanding, right? Our understanding is if we want this number to go up, then we need the number in the denominator in decimal form to be as small as possible, right? This number would be astronomical if we divided by, let's say, 0.000001 or something like that. Then it would go way up, way, way, way up, right? But that's not what we're doing. We were in the 35% tax bracket over here, 25% tax bracket over here. So because we're dividing by a smaller decimal over here, that number went up much greater. Not much, but it went up by an entire percentage point, or almost an entire percentage point. Now here's the problem, right? Is 100% of the yield from each bond, right? Each of these bonds. Like, how do we get these two bonds on the same track? Well, there is the tax equivalent yield that we've already been talking about down here with our tax brackets. But here's the problem, though, is that we need to figure out a way to handle the risk of the two aren't the same. The risk of the two aren't the same. It's not, they're not, right? And so we have what's called a risk premium in finance. Let me clear this stuff out of the way, right? We have this thing called a risk premium, right? Which is additional risk taken by a given asset class, right? By investing in that given asset class. So we need to account for the risk premium. Why? Because the risk of a high yield corporate bond does not equal the risk of a municipal bond. It just doesn't. You're exposed to different risks, and the risk isn't the same. Not just talking about market risk or systemic risk, we're talking about other types of risk. So it's not the same thing. So then how do you figure that out? You need a benchmark. Just like we put a 1 in the denominator for a benchmark, we're going to do a similar thing in the numerator. So how do you do that? Okay, so let's take our formula that we've built so far. So far what we've done is we've taken the municipal bond rate, right? And then we have divided it. Actually, let me do this really quickly. So I'm going to do this. I'm going to hand write this out. So we've taken our tax equivalent yield, and what we've done so far is we have the muni bond rates. I'm just going to call it the muni rates. And we've divided it by 1 minus the tax bracket in decimal form. Remember, the municipal bond rate on the numerator is a whole number, or else this isn't going to work. right? And this is in parentheses. Well, there is a subtraction up above in the numerator as well. So we have our municipal bond rate. And what we're going to do is we're going to subtract out our benchmark to get our risk premium. What we're going to do is we're going to subtract out the risk-free rates. Sorry, my drawing is terrible. So you're taking the difference, so subtraction on the top, subtraction on the bottom, and then dividing. So SSD, right? You can remember it that way. And so what we're doing, let me type this out. This is much better. Let me type this out real quick. So tax equivalent yield equals community bond, let me lowercase this, municipal bond rate minus the risk-free rate all over 1 minus tax bracket in decimal form. And so you can see from these steps, building out the formula, this is what we have, right? This is the formula. You can either view it this way, you can either view it this way, or you can view it this way. But we need that risk-free rate because, again, this is what's going to put the risk component on par with the high yield corporate bond rate. So the high yield corporate bond rate, if we wanted to figure out the risk premium there, we would just subtract the risk-free rate from that as well. Now, normally they don't do that on the corporate bond parts, but you could. Usually the risk-free rate, and some calculations honestly don't even bother with this, especially in such a low interest rate environment that we're in. So using the example, let's say we're in the top federal tax bracket, right? So we're at 37% federal, and we live in California. And as long as you live in the state that is offering or issuing the municipal bonds, you don't pay state income tax either. So which is why you buy them in the state that you live in that is issuing the bonds. So 37% federal rate, still under the Tax Cuts and Jobs Act under Trump, as well as I believe it's 14% California state tax as the top bracket, right? So these are top brackets, ordinary income tax brackets. So now what happens if we are in these brackets? Okay, well, that's a total tax rate. Sorry, total tax rate equaling 37 plus 14, right? It's 51. Yeah, so ridiculous. Tax to death in this country. All right, so that's the total tax rate. So what we're going to do now that we've built this formula and we understand it, right? So tax equivalent yield is going to be, yeah, let's use our same example, 4.5% minus the risk-free rate. Now, if you look up, how do you look up the risk-free rate? You look at the 3-month Treasury bill rate, United States Treasury bill rate, 3 months. And I believe it's 0.45 right now. So let's just say it's 0.5 for ease, right? So that's going to equal 4%, right? And then you divide that, actually, let me just do it this way, divided by 1 minus 0.51. Why? Because we're in the 51% tax bracket. So again, it's subtraction, then division. So what we're going to do now is 4.5 minus 0.5% is 4%, divided by 0.49, right? 1 minus 0.51 is 0.49. So then when we bring up our calculator, 4 divided by 0.49 is 8.16. Usually we round to the hundredths or the second decimal, the second number after the decimal point. And I just forgot what I said, 8.16, I believe. 8.16, 8.16%. That is, if we were paying taxes, then we would, one way you just say it is that if we were paying taxes, then in order to get to in our tax bracket of 51%, in order for the high yield corporate bond rate, remember the high yield corporate bond rate was 7%, right, equals 7%. So in order for the high yield corporate bond to equal the municipal bond, given our tax bracket, it would need to yield 8.16%. Another way of saying it that I like better is the tax equivalent yield when we factor in that we're not paying taxes on this yield, that is the equivalent to a taxable rate, a taxable yield of 8.16%. Now, the simple last step is you take this number, the tax equivalent yield, and you compare it, now that we have apples to apples, compare it to the high yield corporate bond rate. So is 8.16 greater than 7%? Yes. So therefore, we go with the municipal bonds and not with the corporate bonds. But if it was lower than 7%, right, then, which meant, remember, when we did 35% tax bracket, it was equal. It hit 7% rounded. So then we pretty much need to be in a tax bracket 35% or greater in order for this to make sense. So that's how you would say that. So hopefully now you have a better understanding of tax equivalent yields, rather than just giving a formula to you and numbers and saying figure it out. We built the formula, right? So we had to figure out a way to get that municipal bond rate up, and we did that by taking 1.00 or just 1 and subtracting the tax bracket that we're in decimal form, right? That gives us a lower number, which is going to push up the municipal bond yields, because that's just how basic arithmetic works. But then we needed to control for risk, and we did that by subtracting out the risk-free rate from the municipal bond rate. So once again, tax equivalent yield is equal to the difference in the municipal bond rate minus the risk-free rate divided by the difference in 1 or 100% minus our tax bracket. And that's how you get tax equivalent yield. Thanks so much for watching, and we'll see you next time.